So good. Sorry, I wasn't recording. Didn't even realize. But yeah, we're back. Probably gonna only do one question today. A little bit of a quicker day, but I've already started looking at this problem. Um, Minimize maximum of products distributed to any store is just the problem of the day. So here it's asking us, you're given an integer n indicating that there are n specialty retail stores. There are n product types of varying amounts, which are given as a zero index integer array quantities, where quantities I represents the number of products of the ith product type. You need to distribute all products to the retail stores following these rules. A store can only be given at most one product type, but can be given any amount of it. After distribution, each store you have been given some. After distribution, each store will have been given some number of products, possibly zero. Let x represent the maximum number of products given any store. You want x to be as small as possible, i.e., you want to minimize the maximum number of products that are given in any store. Return the minimum possible x. So I already kind of looked at these things. I already know that it is a binary search problem just because there's a minimum and a maximum. And it also tells you here, use the function of binary search for the smallest possible k. To be honest, I've never really done a binary search problem. Obviously, I've learned about binary search in my college classes and stuff, but I just I haven't implemented a problem yet in binary search. So let's take a look. Binary search below, so say hi. First, obviously, we're going to need to define. Probably going to need to define a helper function. When a function can distribute k returns true if you can distribute all of this is the tough part, is that trying to calculate how exactly we're going to do this. So our required store is 0. By in one of these. I know we gotta loop through that. And we loop through this. Man, this is confusing. What is max quantity? Is that turn to just the max number in the array? I have no idea. I think it does. Max number array. Guess outside of this function we can just copy our binary search algorithm. So hello would be reserve right is equal to max of quantities because we want the max value, right? Because you can't have more than the max. Oh, oops. Okay. Hello is less than or equal to pi. If distribute mid y is equal to mid, else we got left is equal to mid plus 1. Turn left. So that's our binary search. Has to be one smallest number of products per store. Can't be 0. Apparently. First iteration. Maybe I have to relook at binary search.
With binary search, our goal is to look through a sorted sequence and determine if the item we are looking for is present, and if it is, where. Let's look at an example. Here we have a list of numbers, or an array in JavaScript. Remember, our list has to be sorted in order for this to work. Now let's say we're looking for the number 4. The first thing that we'll do is take the midpoint of the list. For us, that's the number 7. Now we check to see if the number we are looking for is larger or smaller than our midpoint. Because in our case, our number is smaller, we can look to the left of our midpoint and now deal with only this part of the array. From here, the process just repeats, finding the midpoint again. And this time, our number's to the right. Eventually, after having a couple times, we realize that the number is indeed in our array. Now let's quickly take a look at what this might look like in Python code. Finally, let's take a look at the time complexity of this algorithm and see what it might look like on a graph. We can see that this algorithm runs in logarithmic time, or O of log n. So that's by.
I like that video. That was relaxing. If it's easier if I read the code. Okay. So it's gonna start with our binary search. Well, I guess that's like do a little bit of an explanation. So let's go with 11 and 6. Right. So we're gonna start, our low is equal to 1. Alright, let's just make this left. I don't know why I made it low. Okay. So I'll make it, I have to get rid of this. Okay. What fucking tool do we have, dude? No way. Oh, how do I get out of this? Okay. Oh my gosh, dude. Oh, fuck. Okay. Why is this not working? I don't know. And 6. Hello is 1. Now high. It's equal to 11. Right? So we go through. While our left is less than high, our mid is equal to left plus right. So 12 over 2. 12 over 2, which is equal to 6. Right? There goes our if statement. If distribute mid. Right, so our required stores are 0 for I in quantities. Stores needed is equal to seal. This is meant to be I. Seal returns the lowest, right? Seal. Slowest integer average. Okay. Over 2, which is 6. Stores needed seal. I. Our first value is 11 over max products. Which would be we're gonna do SN is equal to max products is 6, so it would be 11 over 6, right? 11 over 6, which is equal to 1, which is seal, yeah, which is equal to 1, right? Required stores plus or equal to stores needed. So our required stores is required stores, which is 0. Now it's 1. Required stores is 1. So then we return required stores is less than or equal to n. 1 is less than or equal to n. Or equal to n. Now n is, this is our n here. Our n in this case is 6, which is true. That means right is equal to mid. Okay. Someone's fixed me. Okay. Okay, so apparently the seal of this is meant to be 2, so whoops. We forgot to do the for loop, I'm so stupid. Required stores 2, right? And then we do stores needed, which is required stores. So then we go 6 over 6 is 1. This is equal to 3, right? Plus there. Okay. So we return 3. And since 3 is less than n, because 6 is n, we return right is equal to mid. Right is equal to mid. So our right would go up here, I think. So our right would now be, is it 3? Our right would be 3. No, it's 6. How the fuck is it 6? I'm confused what this returns. What does this return? Is it, I thought it would return like true or something. I don't know. Yeah. Right is equal to mid. So okay, so our mid, which I think I understand now. So this returns true. So if this is true, then our right is equal to mid. If it's false, understand. So if it's right, it equals to mid, and our mid here was 11/2, which was 6. And up here, yeah. So then instead of making it 11, we make our right 6 now. So that's 1 plus 7, which is 3. And then we put 3 in here. Right? For ion quantity, stores needed CO I over 3. So I is 11 again, and the 3 is 4. Required stores is equal to 4. And then for 6, we get 2. And that required stores is equal to 6. Since required stores 6 is equal to 6, max products 3 is feasible. We set right is equal to mid is equal to 3. Now our third iteration, we have look at 2. If quantity is equal to 11, is 6. So 6. We're going to do 6. 6 over 3, so it's 9. Since required source 9 is greater than n, max products is equal to 2. It's not feasible. We set left is equal to mid. It's 1 plus 3. Now left is equal to 3. Left is equal to right. Yeah, so now left is equal to, so that we break it about while and we return left. It's 3. Oh, whoops, this is meant to be right. That was tough, man. That was a tough problem. I couldn't really understand the problem. Like, I didn't understand, like, how to think like that. Like, I just don't understand how to think like that. It's just, bro, what is going on here? Oh my gosh, dude. Messed that up. Bro, now we're getting the wrong answer. What the fuck? else left is equal to mid plus 1, return left. That's what I'm doing, bro. What are you talking about, bro? Bro, what? I think this would be way easier if it was fucking mid, because we're passing in fucking mid here. That's what's throwing me off, like. Where the fuck is it right is equal to mid plus 1 minus 1? Where is that? What are you talking about? Like, bro, what? Bro, what the hell? Oh god, yeah. Man, this stuff gives me a fucking headache, like. One line solution, what? if it'll work in Python 3. Yeah, oops. Yeah, that's what I thought it was. It's just hard to think like that. I don't understand how. It's hard to think like that. Bro, what is this? What is he using? A max heap? What the fuck? What? Bro, what is all this? This is binary search too. Jeez. How long have we been doing it for? 37 minutes. Maybe we can do one more problem. Let's try and think like binary search. I mean, we just did a binary search problem, so let's just do another one, because why not? I have to look at some of them too, so let's check out some binary. Let's just do binary search, the easy problem. Because why not? Why not? Binary search. Okay. I prefer doing normal Python, just it's easier to look at, but I don't know. Given an array of nums which is sorted in ascending order and an integer target, write a function to search target in nums. If target exists, then return its index, otherwise return -1. You must write an algorithm of like log1 time complexity of log n. Okay. So we want to do our left. Our right is equal to the length of nums minus 1. Oh shit, oops, length minus 1. So we want to do while our left is less than right. We want to calculate our mid. So our mid is equal to left plus right over 2. Right? Mid is equal to left plus right over 2. If our mid is greater than our target, alright? So if we're on mid, if mid is equal to don't even think this is how it'll work. Then we just, what are we returning? Yeah, I'll put the target is equal to, what are they outputting here? Return its index, otherwise returning. And if min is no, we're doing this wrong. That won't work. No, I'm gonna have to make a function, I think. We're gonna have to make a function. Still gonna work just like this. Binary search. We want to take in our left, right, mid, and what was the other one? Left, right, target, and nums. Okay. While left is less than right. Now mid is equal to left plus right over 2. Mid is equal to target. We can turn mid. Otherwise, else if mid is greater than target, then mid is equal to mid plus 1. Else mid minus 1. Let's just return mid. I don't know. This is probably so wrong, but output null. Jeez. Output null. Output null. Oh, we changed our low, not our mid. Our low is equal to so if our target is greater, right, so if our target else our It's too low. Now left is equal. Now right. Also, it's the other way around. Our right pointer would move to the mid -1. Right up. Ugh. Each hit in the element was not present. What we're doing wrong here. I'm not sure, bro. Let's see. Must be close. Ugh. Oh my god, we didn't even call that function. Whoops. Oh my gosh. Left, right. Target and mouse. I didn't even call the function. Whoops. There we go. Okay. Nice. Oh. -1 expected 0. Oh, we need an equals here. Nope. I don't. Why is this not working? Oh man, again, it's because of the fucking Python, dude. It's because of Python 3. Oh god, I need to start switching to Python 3, man. Okay, this is a regular one. I think in Python 3. Oh yeah. Doing Python 2, dude. Interesting. Okay. Oh fuck it, dude. I'm feeling one more, dude. Let's do Coco eating bananas, dude. Let's just take a look. Cocoa eating bananas. Coco loves to eat bananas. Her piles bananas, the ith pile has. Coco can decide her bananas per hour eating speed of K. Each hour she chooses some pile of bananas and eats K bananas from that pile. If the pile has less than K bananas, she eats all of them instead and will not eat any more bananas during this hour. Coco likes to eat slowly but still wants to finish eating all the bananas before the guys return. Return the number of integer K such that she can eat all the bananas within H hours. There she is. H. Come back in H hours. There's 8 hours she can eat. Okay, right. So she has 8, right? She has 8 hours. Yeah, we're trying to find K. Return the minimum integer K such that she can eat all the bananas within H hours. Okay. So she has to eat 4 bananas in every 8 hours to achieve this. I'm trying to think, like 3 plus 6 plus 7 plus 11 is 27. 27 divided by 8. 3.375. 30 plus 11 plus 23 plus 4 plus 20 divided by 5. Oh my gosh, dude. Again, this is probably like a similar problem to fucking the other one. The first one we just did. Like, I honestly think it's going to be very similar to the other one. Right? I mean, just go to Python 3. Gosh. Alright, so we don't need to make a helper function. That's going to take in a value. Right? But our left is less than right. This is equal to 0. And our right is equal to the length, no, the max, right? The max of piles. Right, because trying to figure out how the fuck we're going to binary search this. Can you eat more than 30 bananas an hour? I have no idea. Like, yeah, I mean, you most definitely must. let's just write our binary search. So mid is equal to left minus right to, alright, it's meant to be a plus. So then we want to do if helper helper mid, we want to do something else. If it's false, we want to do something. And we probably want to return our left because that'll be our lowest value. Right. And inside our helper function, that's what we want to loop for I in piles. This is where I get confused because I don't know. I have to really think about this. If I in piles at each needed is equal to seal, but not is needed. It. Let's just take this. Let's make this mid. How do we think about it? We go. Okay, we have here, we go, our mid will be left plus right. I guess it could be 0, I think. So I guess we'll start at (11/6). We'll start at 2. Right, so it'll be (3/2). Oh my gosh, dude. We need a whole number, don't we? So that's the problem. I don't know how to like really understand this problem, so I can't write what I want to do. I know it's binary search. We gotta think of a way that we can implement this into binary search. It's the issue. Oh, jeez. Let's see. We're using this function to find the speed. That's what we're doing, right? We take divide by 2, right? We have 6 bananas an hour, right? So that's how mid. We're doing 3 divided by 3 divided by 6 plus 6 divided by 6 plus 7 divided by 6 plus 11 divided by 6. .5. To use the total number of bananas and the time it takes to eat them. How to calculate the amount of bananas you can eat an hour. You have 8 hours to eat 9, eat 27 bananas. Okay, I don't know, dude. Now I'm getting cooked eating bananas. Yep, 88 bananas. 88 bananas in 5 hours. Finish 88 bananas. How the fuck is the output 30? Hmm. Okay. Know how to turn this into code. No, can't do that yet. Not mid. I have to be. All right, we're gonna call it. We're gonna call it. We'll come back to this question tomorrow, and we'll finish it tomorrow. But just wanted to keep thinking and keep doing it. Sorry, I'm not very when I'm locked in, I just don't speak. I'm just thinking. That's something that I really need to work on. So when I'm doing these videos, sometimes I don't really say anything or I just jump on my phone. But I'm just locked in when I'm thinking, so it's hard for me to talk out loud because then I get lost in my own thoughts. But yeah. Anyway, thank you guys for watching. I'll see you tomorrow.